There's no question but that if statements are absolutely part of the bread and butter of any programming. They're so useful and so common that processing provides a couple of little shortcuts for a couple of versions of if statements that show up over and over again. We'll look at both of those in this video, but keep in mind that there's nothing in this video that we can't do with a normal everyday if statement. The first shortcut is called the conditional, and it's written with this kind of weird notation with a question mark and a colon. I'll show you how to write a conditional. So here's an if statement in all of its glory. We begin with the word if, of course, and we have the test, and then a bunch of actions that we take if the test is true, the keyword else, and some actions we take if the test is false. Now, suppose you have just one true action and just one false action. Then you can write it much more tersely this way. Here I've abbreviated the word action to statement, or STMT, because I want to take all of this stuff and jam it into one line. And processing will let you do this. You can type this just this way because processing doesn't care about spaces and new lines for the most part. If you do have a line like this, though, you don't need the curly braces around true statement and false statement because there's just one of each. And so you can write this line even more simply this way. Now, this is an absolutely 100% good if statement. But this kind of statement where you want to put it all in one line, there's one true statement, one false statement, and everything is short, this is the kind of thing that the conditional was developed to help you write it even more tersely than this. So let's see how. Here's the statement we were just looking at, and to write it as a conditional, we use a question mark and a colon, and here's how the pieces get distributed. We begin with the test, we have the question mark, then there's the true action, a colon, and the false action. And when this all gets wrapped up as a statement, we end it with a semicolon. So let me show you an example of this in action. 99% of the time, you see these kinds of statements used to assign a value. So here I'm going to assign a value to something called score. And I'm going to pretend that we have some sort of a dart throwing game where you throw the dart and you get a bunch of points if you're in the bullseye and fewer points if you're not. So we'll say score equals, and then it's going to be one of two choices. So I'll call a routine I'm making up called in bullseye. This returns true or false. If it's true, you get 100 points. If it's false, you get 20 points. And of course, we wrap up with a semicolon. This line is the conditional form of the assignment statement. These two statements above and below the line are identical in every way. They have exactly the same result. So if you have something that's this short and brief, you can use the version on the top. If you like the flexibility of being able to change things later, or maybe you have multiple statements or you want to make things longer, well, you can certainly use the version on the bottom. My only caveat is don't go crazy with this. If you find yourself writing the question mark colon form and it goes longer than one line, throw away the question mark and the colon and go with the full-blown if statement. It should really be used sparingly and just for statements that really fit on one line. It's a question of style. You can, of course, make them as long as you want, but that's my recommendation. Let's now turn our attention to the other version of the if statement that I mentioned. This one is called the switch. The switch statement is really useful when you have a single variable and you want to test it for a number of different values. And based on which of the several different values it has, you're going to make several different choices. Let me show you what I mean. Let's go back to our bullseye game. On the left, you can see the general idea. If you hit the bullseye, you get 50 points. If you hit the orange circle, you get 30. If you're inside the white circle, you get 10. And I don't know, if you're inside the gray, maybe you lose a few points. So on the right, I'm showing you how I'm going to write the code for this game. I will take the point where you click with the mouse, and remember, you're trying to hit the bullseye. So imagine in the game, maybe this whole target is moving around, and you click. So we take the click point and we hand it off to a routine, and the routine comes back with an integer. And the integer tells us which circle you clicked in. If you're in the green circle, we get back a 2. If you're in the orange circle, we get back a 1. If you're in the white circle, we get back 0. And if you're not in any of the circles, it comes back with -1. These are arbitrary numbers, but they serve to give me one of 4 conditions. Here's the way I'm going to code this up. I'm just taking those two pieces of information and jamming them together into one diagram. So let's actually write some code for this. Let's imagine we have a routine called find ring, and we don't even have to worry about how it works, but it takes the current mouse position and it gives us back an integer, 0, 1, 2, or -1, and we store that integer into ring hit. If you missed all the rings, we want to say you lose a few points. So let's say you begin by losing 5 points. And then if you're inside the ring, we compensate by giving you points. So it costs 5 points just to pick up a dart. So here's how we might write it. We might say if ring hit equals 0, well, then you get 10 points. If ring hit equals 1, you get 30 points. And if ring hit equals 2, you get 50 points. This is okay, but the code has a couple of problems. One is, I don't like the fact that we're penalizing the player 5 points just for picking up the dart. You should only lose 5 points if you miss all the circles. The second is, I'm not really using else anywhere. I'm making 3 completely independent if statements, but of course I know only one of these 3 things can be true. So let's try this a different way. Here's a new way to write the code. We begin by saying ring hit equals find ring, just like before. And then if ring hit equals 0, we add 10, just like before. But now I'll just say else. If ring hit equals 1, we add 30. Else, if ring hit equals 2, we add 50. And then finally, we have the last else clause. If the value of ring hit is not 0, 1, or 2, then it's something else. In this case, it's -1, and that's when you get penalized 5 points. So this is much better now. You're not losing 5 points right off the bat, and I think the code is clearer. In fact, this is the kind of code that is perfect for the switch statement, because we're testing one variable, ring hit, and we're testing it against several different values, 0, 1, and 2. Let me visually isolate the 4 separate clauses. So here's the part that tests if ring hit is 0 and then does whatever it is we do when it's 0. Here's the part for 1. Here's the part for 2. And then here's the part that gets executed if we're not in 0, 1, or 2. We might say it's the default stuff. This is if ring hit doesn't have the values 0, 1, or 2. We can take this series of if-else statements and turn them into one switch statement. Let's see how to do that. We start with the word switch. This is just like starting with the word if. It tells processing that we're doing one of these testing things, but we're switching rather than doing a general if test. Then we tell it which variable we're testing on. Notice that this isn't a logical test anymore. We're not saying ring hit equals 0 or something. We're just identifying the variable. So we're going to switch. We're going to choose something based on the value of ring hit. Then we have an open curly brace, and at the bottom, a closed curly brace. Inside, we will put our clauses. Something we'll do if ring hit is 0, something we'll do if ring hit is 1, something we'll do if ring hit is 2, and the thing we'll do if ring hit is not any of those. How do we identify which of these is which? We use the word case. So to tell processing, here's the code that you execute. If ring hit has the value 0, we write case 0, colon. And then we give it whatever number of statements we want, followed by the word break, with a semicolon at the end because it's a statement. If ring hit has the value 1, we test for it with case 1, followed by a colon, a bunch of statements, followed by the word break. If it's 2, well, we'll set up for case 2. And then finally, we want the default case. And the way we tell processing, here's the code that you execute if none of the cases above match, is actually with the word default. And then you list all of the statements that come after default. So let's look at the code that goes into these. In case 0, we'll have a line of code. We'll fill that in a second. Same for case 1. For case 2, just for fun, to demonstrate it, I'm going to have 2 lines of code, and default, there'll be 1 line. So we know what goes in here. If ring hit has the value 0, then case 0 matches, and we add 10 points. If ring hit is 1, then case 1 matches, and we add 30 points. If ring hit has the value 2, case 2 matches, and we'll add 50 points, and I'll make up another variable just for fun called center hits to tell us how many bullseyes we've hit. Finally, if ring hit is not 0, 1, or 2, then processing will do whatever is inside of default. In this case, we'll take away 5 points. And this is the exact same thing as what we saw before, except it's written in a switch statement. A couple of things are worth noting. One is the values that follow the word case have to be actual values. They can't be variables. It's just the way processing is set up. So you typically see switch statements written for integers where the cases have integer values just like here. The second thing is there is no break statement after the end of the default case. Typically we write the default case at the bottom. You don't have to, but almost always we do. And there's no break statement at the end because processing just does everything until it hits the close curly brace. For symmetry and consistency, I think it would have been nice to have a break statement at the end of the default, but there isn't one. And if you try to put one in, processing will complain. So what will sometimes happen is you'll have your cases and you move things around and you copy and paste and you change what the default is. And sooner or later, a break statement will show up in the last of these clauses. It happens to everyone. And then processing will tell you, hey, you can't have a break statement at the end of the last clause. You go, fine, and you delete it and everything runs fine. So let's summarize everything we've seen in this video. There are two special case if statements. The first is the conditional, and the conditional lets you write a very simple if statement on one line. And of course, if this is a statement, then there'll be a semicolon at the end. Often this is used as an assignment, but the true and false statements, of course, could be function calls, and you see that very occasionally. The other if form that we looked at is the switch, and the switch takes one variable, tests it against a number of values. Depending on which value matches, it executes the code associated with that value until it hits the word break, or if it's the last entry, the default, until it hits the end of the switch. These are both special case shortcuts. They are meant to make your life easier for the special cases, the special situations where these apply. If these don't float your boat, then you absolutely don't have to use them. Everything you can do here, you can do with the good old if statement. But these are nice because when you do have these situations, it really lets you draw attention to the fact that you are dealing with this special kind of a situation. And that often helps you write cleaner code and also understand it. For example, when you see a switch statement in your code, you know immediately, oh, I'm testing a single value against a bunch of different cases. You don't have to read all those if statements and reverse engineer it and figure out, oh, that's what I'm doing. So now you have a couple of special purpose pliers in your toolbox. Nothing that your standard pliers can't do, nothing that the if statement can't handle. But if you have these special situations, well, you have some custom tools.